Okay, I actually don't see anybody from NDC who can say me if I'm supposed to start. Am I supposed to start? Yes, good, cool. Okay, welcome everybody. My name is Mikhail Svetkin, and today we're going to talk about how to start a modern C++ project. And for those who was yesterday here or today on Keynote, there was talks about where we should use, should we start the new project or shouldn't. I really believe that we should. Maybe not C though, just joking. But I want to talk about how to actually start a project. So a little bit of our agenda. We will talk about my motivation. We'll actually try to create a C++ project. We'll look at the build tools. We will look at the project layout. We will look at the tooling, dependency manager, continuous integration, and few IDEs if I manage to run it. So before we start, a little bit about me. I actually don't like to talk about myself, but this time I will. So I'm principal software engineer at Remarkable. I'm in my teens regarding C++, only 12 years. I kind of like architecture, networking, frameworks, libraries, build systems, and so on. But I want to actually talk about my journey in C++ and C, actually. So I actually started as, my first job was completely bare metal, and it was pure C. And time to time, life go on, and it was introduced some C++ to me, and I was still skeptical about C++ though. I started work on real-time operation systems, and there was more C++ there. Then I said, no, C++ is not for me, too complex, too hard, I want to go to C. And I went to develop Linux kernel, which was pretty good, to be honest. But later on, I had to do more embedded Linux development, and it was C++ mostly. And after I started working on embedded Linux more, it actually was mostly on Linux. I don't know why people still distinguish them, but I just put it like that. After I started developing Linux, it was again C++. I actually went to cross-platform development, and what I'm talking here is about actually Windows and Mac. And later on, I included mobile experience in my journey. And then I later went to work with web, and I started to build libraries, frameworks, and so on. So what was the common in this journey? So from one job to another job to next job, the only common thing which I found was some subset of the C++. The curious was what was the different, and it was a different host environment, like place where you develop. At some places it was just you can develop on Linux, or it's only Windows project, or it's only Mac project, or works wherever you want. The build tools was different. Somewhere it was CMake, somewhere it was Make, somewhere it was Meson, somewhere it was like bash scripts, bat scripts, wherever it was. The C++ standard was different. Sometimes it was C++ 11, C++ 17, C++ 03, C++ 99, difference of them. So the subset of C++ was different. All the companies have their own best practices, and it was like, are you allowed to use templates? You're not allowed to use templates. Is it virtual things is good, or exceptions, or return code, and all these things was kind of different where you go. The libraries was different. So like I highlighted the two common big libraries like Boost and Qt, but there was a lot of homebrew libraries which was used. There are many small libraries. So the project layout was different. It really depends from the company to company. Monorepo, non-monorepo, multi-repo approach, everything in one folder and everything in different folders, wherever. Continuous integration and CI continuous deployment was different. So yeah, let's get this. Dependency management was completely different. Either it was just you have a sources of all your dependencies, or it was a submodules, or was it a package management, or it's like you have to install wherever your Linux distro provide, you know. And the tools, what was different. So what did I learn so far? So everybody used C++, but differently. Everybody builds C++, but differently again. Everybody use some tooling, but with different options. Like you can have Clang format or like Clang-Tidy, but pass different checks or options. So some best practices are the same. I think there is a lot of talks about modern C++. Please don't use new, use the smart pointers. I think this is kind of started commonly adopted across the different areas, at least. So my motivation. And yesterday who was there, I actually asked a question, why and which areas you would start new project. And that reason was because I kind of started work with Rust a little bit. It happens a year ago, and I couldn't say that I fell in love, but kind of I was surprised how easy it is to start a new project in Rust compared to C or C++ ecosystem. So I also played a little bit with Go, and that was not that opinionated as Rust, but still has a lot of kind of default things, which was cool. And CPP front. How many of you know what CPP front is? Can somebody lift their hands? Okay, I will just explain that. CPP front is the Herb Sutter personal experiment. He basically tried to make some new frontend for C++ and convert it back to C++. But specifically why it was interesting, because I saw this slide. On this slide, Herb Sutter basically say, he created one file called CPP front, and he kind of compiled it, and this is the entire project. Like one file project. And I was kind of, okay, let's see how it works. I've never seen this type of setup before, so I decided, let's try it. So let's create a modern C++ project. So this is a pretty standard hello world, and let's try to compile it. I will use the GC first, so we get the hello world and the Clang, hello world. For those who doesn't know CLion, it's MSVC. And suddenly I get the error. Does anybody know what's wrong? Or somebody wants to say something? Okay, then I will say. Apparently for Windows, if you develop for Windows, you need to source this file first, which will set up all your development environment. Only then you're actually allowed to compile and get the hello world. You can also use the Clang frontend or like executable or the MSVC, which kind of works out of the box. So this is a pretty simple C++ project, one file as it was. And my question, is it a modern C++ project? I don't think so. So last year here at NDC, I think it was on the second floor, Timur Domler presented C++ 23, the most important features, and he showed like this is the new way of writing a hello world. So kind of cool. I decided let's give a shot. Let's try it. So I put it on. I created this, and after a few minutes after the presentation, in the presentation of the Timur, he actually pointed out that you can also use import std because we have a modules right now. So I decided let's be super modern. Okay. Now try to compile it. Suddenly it doesn't work. I thought, yeah, I probably should pass std flag to say I want the modernest compiler or standard ever. Still no. I said, okay, maybe Clang is better. And actually, you see that the flag is now different. It's not C++ 23, it's C++ 2b. Okay, still doesn't work. And then I said, okay, maybe MSVC, and again, flag is different. Nope, doesn't work. So I thought maybe this is a Timur line. Maybe it doesn't work. But after Googling a little bit, I found out that there is a way to run it with MSVC. You need to do this. This is basically compile your std module first. And then you can do this, and then it works. Great. So maybe it was too modern. C++ 23, maybe it's still not that adopted. So let's go a little bit back and use print version. Let's try compile that one. Clang say, nope. Oh yeah, it was supposed to be GCC, sorry. But yeah, both of them doesn't support print yet. So both of them will say no. Then the MSVC at least say hello world. So pretty good. So should I go back to use std cout and IO streams to my modern C++ project? Or there is a way to still be modern, but somehow build it? For those who doesn't know, actually std print is based on FMT library. So it's basically FMT library adopted to the standard. They have the same API, so it's std print, FMT print. So I kind of can use that library. And if I try to use GCC, and if you see these three dots, I kind of hide all the flags which I have to pass because they're too big. So I will get hello world. If I compile with Clang, I will also get hello world. And if I use the MSVC, also hello world. Cool, pretty modern. But I still want to use print if it's available. Like, why not? I should use library. So this is what I'm supposed to write in the modern C++. So I need to include the version header, which contains all this, defines what the standard library support is. So, and technically speaking, so if I compile with GCC, it should say check the cpp lib print is not defined, so it will use fmt. And then the same in the main, I will use the else branch to get the hello world from fmt. So it's GCC and Clang. For MSVC then, if I compile, it will actually check that there is a print. I will use print. And yeah, we will use a steady print. So what did we learn? It might be tricky to start a modern C++ project. I just tried, didn't work out, yes? Compilers are not the same, flags are not the same, standard library is not the same. I need to learn all the things, kind of have to. Building is tricky. As I said, I skipped the dots. I didn't show you everything, but it should be done. And code could become messy very quickly. I mean, who said that this is not messy code? Who wants to write something like that? So I suggest we go step by step and try to solve all these problems and see where it goes. So, but let's start with compilers still the same, is building is tricky, so we need a build tool to help us. We have many build tools in C++. Which one to choose? The answer is CMake, to be honest. Kind of, it's de facto the standard build system nowadays. And kind of semi-prove my point is this is a question, it's from the JetBrains survey, developer ecosystem. So most of the people answer CMake is their build system. I'm not fan of CMake, to be honest. But there is a good quote. I'm not sure if you can see it, but I will just read it. I'm on the record as liking CMake as Stockholm Syndrome for C++ engineers. It has become de facto standard, for better or worse, as demonstrated by the clear lead it holds over its competitors. So CMake is highly adopted everywhere. It's adopted by IDEs, it's adopted by many big projects, like Qt recently have been moved to CMake, embedded people moving to CMake. So there is a lot of movement to the CMake, for better or worse. Also, C++ developer survey light kind of shows the same, that CMake is majority, so is how it is. I have another argument to prove that CMake becomes de facto the standard. In the same C++ developer survey, there is this. It's one of the top major points. So it kind of proves that CMake is so important that it's pain point now, one of the topmost points. But there was other interesting pain points, like how to set up a development environment, how to set up a continuous integration pipeline. Oh, sorry, that's not supposed to be. Managing libraries, my application depends on. So I promise you we will hit all of these pain points while we're doing our project, to be honest. So let's start with CMake quick intro. As I said, I'm not fun, but we have to go through it. So meta build system. CMake technically doesn't build stuff. It basically generates some specific build files like make files, ninja files, Xcode files, wherever files you want to use as a generator. It's cross-platform, works everywhere. It's configurable-ish. I said this ish because you saw the pain point. It's hard to manage. So you can configure so many things that it's impossible to manage after that. I will also say it's scalable because you can do a lot of things. You can put a lot of things, but monorepo will not work. One changes in CMake file will trigger rebuild the entire world. You don't want to do it. So please don't do monorepo with CMake. Or at least if you know how to do it, tell me, because I would love to learn. Okay, let's try to look at simple CMake example. So you need to add a file called cmakelist.txt. Yes, then you create, this is the content of the file. So you define the minimal version of CMake. You need to make a name, say what languages do you want to use. We define a target executable, then say source files, in this case main CPP, and then you can say whatever standard you want to use. Or do you want to be with extensions or without? So Then we have to build it. And the CMake has different types of steps. So first it's configure, second it's build, and then you can do wherever you want. So the first step is building, configuring. So it's like CMake dot usually is to configure, but if you don't pass the build folder, it will configure in your source code. So your source folder will be messy. So CMake is kind of as C++, has a bad defaults. So you have to specify it by yourself. And then you can build, you say build and in which folder you want to build. And then you can run your application. Hello world. As you can see, CMake has a bad defaults at this point, and sometimes the project has many different options you need to pass to configure the project. Do you want to use these or these? Blah, blah, blah. It's kind of hard to share. And recently, CMake came up with a thing called CMake presets. It's basically a JSON files where you can describe how you want to configure, how you want to build, how you want to test, how you want to create a package, and how you want to run it on CI. And basically, it's two files. One is CMake presets, which is default, and the second one is a user, your custom, you never put it in your repository. So let's go through it quickly. Okay, so first is basically a configure step. So this is an example of one of them. So you make a name of the preset. The presets could inherit another presets to kind of share some common things. Then you say what kind of generator you want to use, like for example, in this case, Ninja multi-config, or you want a Ninja, or it should be Xcode, or it should be Make, wherever you want. Then you can put the default binary dir where it's supposed to be. And presets support this, they call macro expansion, where it's basically this $source dir will be expanded wherever your source code is. And then create build preset name. So it will be your project build base, for example. Then you can also specify CMake toolchain file, which maybe you have some custom flags wherever is there. Maybe it's a vendor provided. You can also set default cache variables. It's basically like I want to build my project with this library, for example. Then you can specify some environment variables because sometimes some build parts depends on some environments. And then you can make a condition when this preset is available, for example, that maybe this preset is only for Windows, or it's only for Linux, or only for Mac, wherever you want it. And then to be able to execute it, you just need to say CMake preset, the name of the preset. If the preset is available, then that will work. Yes. So the next step is to build. And it's the same syntax. You say what's the name. It could inherit from another build presets. You need to point to configure preset. Basically, it needs to know where to find the build folder. You can define what kind of targets you want to build. Maybe for this type of preset, you want to build only one library, two libraries, three libraries, maybe one executable, wherever. The same environment variables, you can also enable conditions. It's only for Windows, for example, or something else. I don't know. Never used that one actually in this case, but. And then what you could do is, so our base preset for configure was Ninja multi-config. So then you say CMake build preset base, and that will build the project, basically. You can also specify --config to be able to build either debug or release, or minimum release version, or release with debugging for there's something like different names. CMake supports by default 4 different types of configuration. But basically, this config flag affects like, do you want to enable optimization? Do you don't want to enable optimization? So basically, that's like it. Then you can ask CMake to actually run your tests. They have a specific command called ctest. And you have, again, the presets there to describe. Again, name, inherits, configure, to know where the build happened. You can then specify execution policy, like how the ctest want to be. Do you want to retries? Do you want to output in that format? Do you want to use that amount of CPU power and blah, 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 parallel it, and wherever. And you can also specify the kind of, to be able to run it, just say ctest, --preset, and the name. And then you can specify the, like, do you want a debug version to run or release one? So it's kind of pretty similar in all the scenarios. One last thing, not last, but almost, is Cppcheck. Cppcheck is another tool from CMake, which is actually making a package out of your project. And it's the same syntax. You give a name, you say configure preset, and then you want to say what's the generator you want to use. In that case, targz, which means wherever we build our project, now I want to pack it in targz, and now it's kind of, I can share it to somebody, for example. And again, you can specify which version you want to use. Do you want to use produce a debug version or release version? Up to you. So, and then there is a workflow. It's pretty recent, happened to be. And the point is, like, instead of building all these 4 different commands like configure, build, preset, or test, pack, you kind of can combine it in one and just say CMake workflow, and it will configure, build, execute tests, and make a package for you. So it's kind of nice for CI. Maybe not only for CI, if you just need to build something for somebody. Yeah. One of the problems with presets which I encourage so far is the names, because they kind of wherever you want, and good naming is always hard. So I come up with something like that. It's not Mix, actually. I take it from LLVM. I took it from Cargo. It's basically architecture you want to build for. What's your OS target? What's the compiler? What's the linkage, like dynamic static? So it's kind of like this. x64 link GCC static, or like GCC dynamic. I will produce dynamic libraries instead of static version of it. Or I can say Windows MSVC static, something like that. It's kind of good in a way. It's a little bit verbose, but it's just unified, the same, you know, and you know what's actually built for. It's kind of important when you try to build from many different targets. But it's just my names, so feel free to not use it if you don't want. Yeah. So how to structure a C++ project. So we kind of learn about CMake, how it works, but you remember the pain point. It's kind of hard to manage it because it grows bigger and bigger and hard. So to answer that question, I found a very nice presentation by Mateusz. He actually talked 1.5 hours about the Conan and CMake, and I really recommend to watch that one. I think this is kind of his second version, he one before, but this one is really good. So I will just briefly tell what he recommends to do, and we can look through it. So what he proposed is basically you kind of divide project in a couple of sub-projects, and everything on the root folder is basically, this is entry point for the developers. These CMake tend to be only used by the developers. You can enable all the features you want. You can enable extra warnings. You can enable build testing, documentation, cache, and whatever you want. Maybe you have something else there. And then you have a second level of it, and it's kind of source, everything what's inside the source. It's also a standalone CMake project file, where actually it's entry points for consumers. Like, you kind of never knows who is going to use your project and how is going to use your project. It could be somebody added you as a subdirectory or a Git submodule, so they don't really want to build your tests as part of their build. So it's kind of nice to have this isolated source project, where only thing is there, it's actually define how to build the project, and everything else managed by somebody on the top. Yeah. And then inside of source, you can see like such modules or applications. It's basically every single feature of your project is a separate folder. It looks similar. You have source include CMake, and you describe how to build it. And that way is kind of, you don't want to build it, you just disable it. You comment out that subdirectory and it doesn't build. So it's kind of easy and nice to configure, and it kind of keeps your project a bit clean, I would say. So, but that was a theory, so let's try to add it to our small project. And before we go, I just remind you, this is how source code looks like. And I guess my proposal will do something like that. So what's here is happening is that we kind of say, when we compile with GCC or Clang, we say NDC print will go be actually FMT print, or actually it should be NDC login back, but it really matter. And on MSVC, we kind of call std print. And everything else is hidden in this debug header. So let's start with simple adding the CMake, and I will use the Mateusz way of making the CMake project. So basically, this is how the root CMake file looks like. We define a project. We explicitly say this is a developer project. You're not supposed to kind of use it any other way. There is a CMake magic which you can use to make sure that this is only like never used as a subdirectory and nobody else using it outside of kind of this always root. We're not going into it. And then you kind of enable all things what you want, like C cache, maybe extra warnings, maybe docs generation, maybe, I don't know what you want, dependency manager, everything what you want. And then you source, add subdirectory with sources. And as I said, show like later you enable testing. So the source folder looks like that. It's also the project. It says NDC in that case, no dev prefix, so it's kind of 10.2. There is a small little function called add NDC module. I'm not going to look in that one, but it kind of hide all the complexity of CMake, I would say. So you don't really need to worry about that. You can look at the bit later if you want. And then I add my two modules, in that case log and actual executable my app. So let's take a look at the log module. Let's look like this. We say add NDC module. And I said, let's don't look into what this function does, but basically it says add library and kind of default options like C++ standard and make sure that it's possible to install the target and blah, blah, blah. It says interface because it's actually header-only library, and in CMake you have a distinguish between header-only libraries or not, and if you want to have a header-only, you need to mark it as interface. Yes, then you source the, say which sources you want to use, in this case debug HPP. And we say if it's not MSVC, then we want to find FMT package wherever that comes from, because FMT is a library, it should come somewhere. But let's assume for the simplicity of right now, it's actually already installed on my PC somewhere, my Linux distro or Mac provided for some reason. So then I found the package. I say link libraries, so I kind of say my library depends on FMT. So now everybody who depends on my library will get the FMT. And I say like, because we will have to do ifdef later, we kind of need to say like, now I build my library with use FMT. And then now a header will look like this. So we say, if define NDC use FMT, then use FMT core. If not, we will use print. And I'm not going to show you how to implement the debug. It's kind of simple. It's also the ifdef basically. So it's not the point. But I want to highlight another one, how to actually test your headers or everything. And in Mikhail's project layout, you basically have test folders, and it's kind of above the source. And it's repeat the layout of wherever was in source. So in this case, we have test log. And we have one test, which called debug_test. And it doesn't do anything, but just include our header. And it's quite common to do it, because you never know what's your header actually includes. Maybe it's missing some includes. So just this sanity check will try to build that empty test and make sure that maybe there's some missing includes or something. So it's good to test just without anything. Yes, and then my executable looks like that. Again, I have a simple wrapper function which sets the defaults, and then I source the main CPP and I say I depend on NDC log library. So kind of simple. So let's try to build it. And I basically say CMake workflow, select my preset, build it. It will run all the tests, so I'm quite sure that they pass, and then I can run the application. I will get my hello world. And then you can say, well, now I want to test it with Clang. I'm on Linux, I can do different compilers. I like it. So I tested, everything cool. And now I kind of want to share my project with the world, because I already done it. I done the setup, and this is my silly attempt to switch to this topic of version control, because in my journey, I've seen that the people share code by sending the emails with attached target Z. or like zip files, and it's like this is just a nightmare how you manage it. So I hope everybody use already version control. Nobody's still doing that or not using Google Drive to synchronize. So that was, I said, just my silly attempt to switch to that topic. So yeah, I will just say yes. Why do we need version control? It's a history tracking. You know what was there. You know the attention, who thought something to do, why he implemented that. It helps the collaboration work. It's kind of nice to have a backup and recovery. During this presentation, making this presentation, I several times broke my presentation in Google Drive. I was like, I have to restore it because I accidentally pressed the delete button and it's deleted. And then I close the window, then like I need to open it. With version control, you don't have this problems. Kind of nice. And I want to say choose wherever suits you most. I personally recommend Git, GitHub. Feel free to do wherever you want. And before we go, I just want to say small tips and tricks. It just was a discovery recently for me. So very often when you do a huge refactoring or changing the like a code style or like apply sanitizer and then go fix everything. Like if you do massive, some robust changes, like I would say the good example is technically apply the new style. Then your entire Git history is kind of broken because every time you do git blame, it says like update my style. That's kind of silly. Apparently there is a mechanism, so git blame ignore refs file. You can create that file. You can say which commit SHA you want to exclude from the git blame. You can put it there, and then when you do git blame, it will skip. You will still see like the reason why that code exists. It will ignore your update clang format, and you can always opt out of it. And the reason I want to specifically highlight it is that actually Git doesn't have a net kind of built-in integration with that file. You actually need to specifically say, Git, please use that file for me. And the reason why I'm saying is that because when you say that and then you switch to, imagine you have multiple branches and you didn't add that file in the beginning. And then when you do switch to a branch which file doesn't exist, you do git blame, Git doesn't work anymore because it says this file doesn't exist. So please, when you create a project, add that file as early as possible. It could be empty, but then you will don't have a problem that git blame suddenly doesn't work. And yeah, and use git ignore file, please. There's a lot of build artifacts usually and some IDs or something. Please put something there. It's nice to have. So, okay. Let's, since we know version control, let's share with a friend our project. So I probably will publish it, but just showing git clone, go to the folder, and my friend is on Linux as well. He tries to build and suddenly it doesn't work. Remember I said for simplicity is that FMTs has been installed on my PC and it hasn't been installed on my friend PC, and he doesn't know how to install it or which version to use, so it kind of doesn't work. I think we almost get closer, but now it doesn't work. Should I remove FMT? Should I wait print or something? No. The answer is I should use the package managers. And if you're wondering why you need the package managers, I actually last year at NDC did talk about that. So I will just show this small slide. It's from my talk. And it's pretty small. You will probably not see, but this is a building Qt 5 from source. And you can see, if you try very hardly, is that for each of the Linux distro, you need to install specific package to be able to build it. I'm quite sure this documentation is out of date by now, but it's just only part of it. The entire page, how to build Qt from source, is like a couple of A4 format pages. So you really want to, and mostly it's about like what kind of extra third-party libraries I need to install. So you kind of want to avoid it, because this documentation is always out of date. Like we showed the example with strict, what was there? During the keynote, there was like strict overflow or something. And it was like in GC documentation, but it was deprecated many years ago. So kind of, I prefer if you have a build tool, which kind of builds everything for you, and you don't need to worry about these things. So, what kind of options we have for C++? And so far we have two options, in my opinion. It's a Conan or VC package. There is others, but I would say they're not that mature. and all the in the same JetBrains or ISO CPP server, you will see that Conan vcpkg is dominating, kind of. So I will talk about them. And I personally like vcpkg, so I'll show you how to add the vcpkg, but choose what we want. I'm not again for vcpkg, just saying. Choose wherever you want. So let's add the vcpkg to our C++ project. And vcpkg has a pretty nice CMake integration. Remember the presets? Remember the toolchain file? You just need to point to the vcpkg.cmake, where to get it from. And that's all good. Everything is done. Now you just need to add the vcpkg.json in your root of the project. Save each dependency you want. In my case, it's FMT and catch, because I write test and catch, and FMT is dependency. You can also say that I want to use FMT only for Linux or Windows, or like you can choose where to install it, but for the simplicity, I didn't bother to do it. So now let's share with a friend again. So yeah, I do add the changes to my Git, I do commit, I push it, and my friend does a pull, try to build. And now we see this couple of messages saying like vcpkg running install the libraries, show the versions, and now kind of building testing is done. You can run the application, it will work. Okay, very good. Let's share with the friend number 2. And apparently that friend is on MSVC, on Windows. And so far we've been using Linux. So that's what happens when I compile with MSVC. Does anyone can understand what this error says? It's actual real error. I run it. Can someone understand what this error says? Any guesses? Okay. I'm not sure if you noticed it, but I specifically did a mistake when I was doing my presentation. So I kind of wrote print and added extra space. But because it was MSVC and I always tested with this kind of Linux, I never run into that branch. So I've never tested that code. And this is again my silly attempt to go to kind of continuous integration. And why do you need it? Because the thing is that with C++ is kind of, you think that you manage to make a project that works everywhere, but then you start to run it everywhere or build it everywhere, it doesn't work. It works on your GCC, with that version of GCC, or with that version of CLion, but suddenly on Windows it doesn't work. Because there was undefined behavior, maybe you didn't understand the standard, maybe use it wrongly, maybe just this GCC just optimized it out something for you, it worked, but didn't work for MSVC. And as I said, in my case, I just this silly mistake. I just made a typo. And still you cannot build anymore. It's simple to fix, but it's nice to avoid these problems. And the bigger project become, and if you've been only on GCC for a long time, there is a huge change when you will try to compile a project with MSVC. It will take a couple of months, depends on the size of the project, to actually make it workable, or buildable at least. So I ran multiple times in that problem when you like use GCC all the time, and then you started to use MSVC, and suddenly things doesn't work. So yeah, continuous integration. And I think kind of explained why you need it. Basically, it's to test your code on different platforms, even though it's not maybe your target platforms, because the compilers are different, the standard library is different, and it's nice to get more overview. We don't have a good tool chains around to tell us, oh, your code is wrong, like in Rust, for example. But yeah. So what to do with CI? I would say build at least on 3 common platforms, Windows, Linux, Mac. Try to use the 3 main compilers. CLion can support stdlibc and libc++, so it's nice to test both of them. They're a bit different, so you can get the different results. Pretty nice. I would also say build at least debug and release versions, because they are different. You build with the different flags, you can get the different results. In release, compiler is allowed to optimize more things out, so I saw it very often that release works, but debug doesn't, for example, or opposite. So it's kind of nice to have. And again, if you had a project for a long time, it was building only in release, there is a huge chance that debug will not work, for example, or opposite. And I would say run at least Cppcheck and Clang-Tidy. This is kind of Cppcheck and Clang-Tidy is analyzers. They analyze your code and recommend to replace something. So it's like a minimum set of things you could do. Yeah. Let's add the GitHub Actions. GitHub Actions is GitHub provided CI. And I'm talking about GitHub Actions because it's kind of free if you have open source project. So it's quite nice to use, and they have Windows, Mac, and Linux. They have a lot of things around it, so kind of pretty good. So I'll just quickly show how to do it. So you need to create a YAML file, name it, tell when to run that action, in this case on push and pull request. You need to tell on which OS you want to run, and I use the matrix target. We'll talk to a matrix a little bit later. And then kind of you need to define your test matrix. So in this case, I want to say I want to test on Ubuntu latest and use this preset. I want to use on Ubuntu latest and use this preset. Windows, this preset. So this is kind of matrix. And then I will get all these variations to run. And the simple steps of test would be, you need to install some system dependencies. GitHub virtual machines come with compiler, CMake, and without Ninja for some reason. But sometimes CMake is out of date. Compiler might be not which you're targeting. So you will have to do some, like if I'm on Windows, install that one, on Linux, that one. And maybe you don't want to use Ninja, maybe you want to use something else. So you need to install some system dependencies. Or like, for example, you install Qt, and Qt requires on X11 some system dependencies. So you will have to kind of install it anyway. And then the simple, easiest test you can do is run your workflow. And as you see, it's kind of pretty simple and easy. Just by doing that, you will make sure that your project at least can run these tests, C IDE tests, and try to make a package if this is what you want. You may disable the packaging if you don't need it. But this is quite simple, and it's kind of allow you to make sure that your project is kind of work, at least builds and run tests. And just to show that this is what people have to do nowadays, I will show you an example of actual pull request. It's FMT library, which we're using. And it runs 40 successful checks in this case. And you can see it using different types of GCC, release, debug, Windows, macOS. It's also fuzzing itself, build documentation. And FMT is widely used in C++ community. So this is what requires to you to make sure that your library works everywhere. Without that, you cannot say it. And there are still bugs in that library. Still something hasn't been tested. Still, and you can often see in FMT libraries that like a new GCC came up and that doesn't compile anymore because there was some new improvement which was not catched before. So the guy can go and add this compiler to the set of compilers to test. So it's kind of our life. So, but with the nice GitHub setup, it's kind of not that hard to do. It's basically install another compiler, the same preset, so kind of should be easy. And if you look at his workflows, they're kind of easy. You can just copy paste it if you want. So let's imagine that we have everything now. We have a CMake, we have a project layout, we have a project, and we have a little bit of tooling. So let's a little bit more talk about toolings, and I will just define my minimal set of the tooling, which I think is good. So I would say use formatters, and I would say Clang format to use this, have the same style of the code between your projects or inside the project. I know people don't like it. Some people don't like. Some people like to be. They don't like what kind of Clang format gives you as an output, and that happens. Clang format is not perfect. But I think it's better to have a tool than don't have anything, because I've been in the companies where every PR starts with, oh, you know, there should be 2 spaces, or bracket should be close here or close here. Like, just use the tool. I want to spend time on actual code writing, a logic architecture, rather than caring about style. And I would say if you have a git blame, git ignore blame ref file in the first place, you can always update the Clang format rules and update your repository. It will not break your history. You still can work. I would say it's better than don't have it at all. But again, choose what you want. There is apparently CMake format. I was quite surprised, but it's kind of cool. So CMake become that powerful language that you need to format it. It's actually have a CMake lint as well. It kind of verifies that it's a valid CMake file, which is quite impressive. We have like in C++, we're not so cool that we need so many compilers to verify that our program works, but we need a tools to verify that our build system works. Some kind of impressive. Yeah, so I would recommend use linters like Clang-Tidy. It has a bunch of checks to verify, like CPP core guidelines, some Google checks, some LLVM checks, some many different things. And most of the time when it tells you, you really did a mistake. So I really recommend to use that one. Clazy, it's specifically, I think it's based on Clang-Tidy, if I remember correctly, or correct me if I'm saying something wrong here, somebody. But the Clazy is mostly focusing on Qt projects. It's kind of give good recommendations, so I also recommend to use it. Cppcheck, pretty simple static analyzer. Good enough, I would say. Include what you use. You know, you've probably been working on the projects where you have a file which includes half of the world of your project, and these tools kind of help you to say which one is actually needed or which one was just because you refactored it and forgot to remove it, because it's quite simple. I would recommend to use commercial linters. There is PVS-Studio, there is Sonar, there's maybe something else, but this is what I used before. And I'm surprised how many things they found. It's like in case of PVS-Studio, they constantly take some open source projects and they run it and they show the mistakes which they found. And it's like, how did it work before? So pretty amazing tools. So I would also specifically select one thing which recently found out. It's called pre-commit. And the pre-commit is the framework around the different commits, pre-commit hooks for Git. And just a little back to the Clang format, I said that it's kind of doesn't format it good, but it also, if you bump a version of Clang format, it might be incompatible with the previous one. So, and then usually Clang format is distributed via your package, like system package management, like in Linux distro, you install the Clang and you get the Clang format. So that's kind of hard to have the same Clang format version across the project if you are on different platforms, different Linux distro. Pre-commit kind of build that framework around to kind of, and Clang format is a hook there, which says, I want specifically that version of Clang format. That kind of help the project. And it's also have so many different hooks there, like the list there is, I don't know, so many different, it can check like if you've file ended, if you have an end line or don't have end line, that's different many things. It can run all of these linters if you want. So it's kind of good. And the good of that tool is that it can run before you actually do an actual commit. So you get a very fast feedback. You don't need to go to the GitHub CI to verify, oh, actually my one of these linters told me that I did something wrong. So it's kind of fast feedback, easy to fix. Then you go and push it. And the pre-commit as well has a CI version, so you can make sure that whatever people do locally is the same in CI. So I would say quite cool thing. Even though some people don't like it because it requires Python, so now you need Python in your setup. But yeah, okay. I think it's price to pay. And then I had another argument I heard recently is like the guy was kind of refused to put the Python in his ecosystem. He said, like, I don't like Python. Python is not my language. And he was like, why should I need this Python to build my project? And after hours of talking, we managed to convince him that it's good. So I think it's worth it to make sure that there are people who kind of have their own view of things. We should respect them by all means. And regarding the C standard C++ toolset, there would be a awesome talk from Anastasia Kazakova. She works at JetBrains, I believe. And I saw her talk on CVP on C, and it was amazing. It was actually, we'll go through C++ tooling and explain what's the difference between other languages, what we have now, and so on. So I really recommend to go there and listen. It's kind of cool. Okay, so we kind of learned that we have a build tool, we have package management, we have a project layout, we have a CI. So, but that we spend almost an hour to build it, yes? And not everybody wants to do that. So what do I do if I just want to write a code? I want to focus on the code, C++, logic, architecture, wherever it is. And I would say to do that, you need to select a good IDE. I personally love Vim, but I spend years to configure it. So I would say like this. Vim and Emacs, it's not IDEs, it's text editors with a lot of plugin. You can build out of IDE if you want, but you have to spend a lot of time to configure it to find what suits you best. I have kind of removed VS Code because it kind of text editor, but it has a lot of plugins. It's kind of eager to install it for you. So kind of, at least if you're a new person and you want to start a C++ project, VS Code maybe not that worst option because it kind of tells you, oh, you want to do C++, let me install CMake plugin. Let me install C++ plugin and blah, blah, blah. So like this. But as I said, I personally use Vim, but as I said, I spent years to master it for myself. So I don't think that everybody wants to do that. So yeah. I thought about what kind of IDEs there are in C++ world, and there's many, but I decided to highlight two. It's a CLion from JetBrains. It's a commercial, actually, but really good one. And there is a Visual Studio, the Visual Studio which actually on Windows, not which one on Mac, because on Mac it's kind of half, it's not the same. I don't know why, but it's not the same. So, and by this reason, because I'm on Mac right now, I cannot run Visual Studio, so I will talk about CLion, actually. And I will just say a little bit of why you should choose the CLion, even though they didn't pay me for the commercial, but I will. So it's the most complete code model which I saw. It kind of knows so much about your code. It can tell you so many things which you didn't know. And they basically based on Clang-D, but in the same time, they have a lot of their own things. So it's kind of Clang-D plus more, which is good. It has bundled C++ tooling. It can give you CMake, it can give you Clang format and Clang-Tidy. It has a lot of tools with it. So if you just start the project, you press it, and it will give you everything, kind of. It has actually even integration with Conan through the plugin provided by Conan, but they also have native support of vcpkg. So you kind of get everything what you need from scratch for the beginner, for the new project. Feels like a good thing, in my opinion. And it's also actively developed and maintained. They constantly release stuff, so it's kind of good. And you can always write them feedback, and they kind of, in my experience, they kind of reflect on it and make something better. And it's kind of Emacs-like user experience for those who love Emacs. You kind of just leave in that IDE. You don't need to go out. It has everything, integration, as I said, with all tooling. It has integration with Git. It has integration with GitHub. You can just leave there and don't do anything. And question, how many minutes I left? Only 5 or? Sure, okay. But I wanted to actually try to open it at CLion, but I'm not sure if this setup will allow me because I have this mirror screen and it's kind of troublesome. Oh, not the extended screen. Let me just try to, if I able to. If not, then we will just keep it. How to do it? Oh, I don't understand this thing. Yeah, options, no. No. Mac is my machine for presenting. I actually never use it by default, so I don't really know. But let's see if this works. If I do like this, no. And I think I will a bit struggle, but yes, yes, and then I don't see anything myself. Okay, I don't know if I can. Yeah, okay, I will do quickly show some stuff and like remember, I barely see what I'm showing, but so sorry. But this is a CLion and I just opened one of this is my CLI and I have this thing. And imagine if I'm a beginner and I don't know how things works. I don't know the CMake commands, presets, wherever is there. I don't want to. Like what I want to do is this, what was supposed to be, I think this one, yes. I'm supposed to just run it. And it knows how to build only that specific target, how to run it and show me hello world. You know, it also here has kind of integration with Clang-Tidy, Clang format. I can mess my code and I think let me try if I can do it. Yes. And it will format it back because I have a Clang format. So like I can do whatever I want. In the end, it will put it as it should be. So I can be crazy as I want. I also want to show, yeah, okay, maybe this. But as I told you, we have a complex build system, and CLion is actually allowed to debug the build system. You know, it kind of sounds crazy, but you can do it. I'm just not sure if I can press it here. Is it? No, not. Sorry, but yeah, I wanted to show. What is this? Yeah, whatever. Sorry, guys. Yeah, but I want to show like you actually can run the debugger. I just barely see what's happening on the screen. Not the best setup ever. But yeah. So yeah, I just recommend the CLion because it has a lot of good things into it by default. And if you're a beginner, it's nice to start. But yeah, choose what you want again. So how do I actually start a modern C++ project? We went through that together, we built it, and while preparing this talk, I actually created a template which you can use. It's public. It's not full, it's not complete, but it has all the CMake setups, Clang format, base CI, all the presets. You just need to create a template. And as I said, I don't love CMake, but I wrote the CMake script which actually go and rename your, like you need to say what's the project name you want to create, what's the first module will be, and what's the first header will be, and it will rename it and make it as a template. And if you look at this history of that repo, I actually initially tried to use bash and bat scripts, but you know what I failed is? I started to do init shell script, and I used seed to do replacement, but apparently my approach was incompatible wherever seed version is on Mac. So I was like, on Windows, there is no seed at all. So I'm thinking, but if you want to start a CMake project, we have a CMake language. Okay, I can do it. I actually asked ChatGPT to help me to build that script. As I said, I'm not a CMake lover, but after a lot of tries, you will see in the history, it's all there. I didn't hide anything. I managed to make it, so feel free to use. My template is, as I said, mostly based on Mateusz template with a little bit changes with presets in place and vcpkg integration. But yeah, you can go to Mateusz as well, or there I know that Jason Turner also has his own template. So please check it out. Yeah. Thank you. That's all. I have some links, and if you have questions, yeah, feel free to say. Yeah.